In this video, we will cover the basic syntax of propositional logic. So, first of all, when you talk about syntax, what are we referring to? What is syntax? In logic, syntax refers to the formal structure of expressions. So, the rules that tell us how to write valid statements. For example, in propositional logic, you can write something like P and Q. We will look at this in a minute. But you cannot write something like N, P, Q. So this is a valid statement. This is not a valid statement. So syntax defines what symbols are allowed. We have something like not, and, or, implication. We do not have something like this. I don't know what this is. So what symbols can you use? Syntax will tell you that. It tells also how you can combine them. So this, as we said, is a valid combination. This is not. It also tells you how to use parentheses, and in a nutshell, it tells you what counts as a well-formed formula. Sometimes you will see this referred to as WFF, a well-formed formula. So when we talk about syntax, we're talking about the grammar of logical language, what you're allowed to write before you even think about whether it's true or false. So let's dig into it. Let's recall what a proposition is. So if you have something like 2 is even, well, this is a proposition. It can be evaluated as true or false. In this case, it is true, so it's a proposition. And the thing is, in logical proposition, we usually use letters like P or Q or R to represent statements and propositions. So we could call this P, for example, and we can combine propositions to form more complex statements. So we could have another proposition, for example, 3 is even, that we could call Q, and then we would be able to combine them to something like P and Q or P or Q, etc. These symbols are logical connectives. They are symbols that we use to build more complex propositions. So first we have not, which you'll see a lot. So we have, for example, not P, which is the negation. So for example, if P is 2 is even, then not P is 2 is odd. Or you could say it as 2 is not even. It's the same. Then we have and. So P and Q, this is a conjunction. So for P and Q to be true, both P and Q have to be true. So this is not, this is and. Then we have P or Q, which is a disjunction. So this is or. For P or Q to be true, at least P or Q have to be true. At least one of them have to be true. If both are true, P or Q is true. If one of them is true, it is also true. If both are false, then it's false. Next, we have the implication. P implies Q, or you'll also see it written as if P, then Q. This, as I said, is an implication. If this one is a little harder to understand, we'll see it in greater details in other videos, but for P implies Q to be true, P has to be false or Q has to be true. So if P is false, it doesn't matter the value of Q, this is true. If P is true, then Q has also to be true. And finally, we have P, if and only if Q. This is known as a biconditional. Sometimes you see it written as if with two F's, so if and only if. For this to be true, P and Q must have the same logical value. So if both are false, then this is true, and if both are true, this is also true. If they have different logical values, then this is false. And then you can build compositions using these symbols. So let's see an example. You could have something like P implies Q between parentheses, and we're actually negating this. So whatever logical value P implies Q have, we're actually negating it. So if it's true, then our full statement has a false value. If it's false, the statement is true. And this kind of composition can get as complex as you want.